So, okay, guys, let's get started. Today's session. Yesterday, we spoke a little bit on the introduction of extremely basic commands on Linux, and today we'll try to actually go on the shell-based commands. So, understand shell programming a little bit and its basics, and give you guys at the end some of the assignments which you can try complete. Okay, and also that coming week is a little bit tight schedule for me. So I'm not sure how much time if I can contribute to you guys. I will let you know the schedule via mail, okay, to all of you. Satya will or somebody from Sunil may be contacting you on the schedule, okay, if there is any change in the plan. All right. So first we'll take a very quick view of what a shell is. And we'll talk about, of course, there are two types of shell. One is a command line shell, and another one is a UI based. And you'll see that the most prominent, what we are going to focus on, the command lines shell. Now, if you ask from a user perspective, shell is a program or an application. Okay. Running in the user mode. It takes input as another program or an application and executes them. So primary role of every shell is something like this. It will take certain input, and then that input usually is going to be another program, and that program will execute. Okay. Now there are several types of shell. We spoke about them. It's an environment, you can think, where anything you want to do, you have to use a shell. It's a primary way via which a user can interact with the machine. Right? You want to know something about just we saw we type some command. So it's like a query. You're giving ls. So ls is a separate program. Somebody has used some directory and file system based structure system calls, written a C code, converted into an exe file, and that is a part of your root file system distribution. So whenever you run an ls, it's an exe program which is running on there. How does it do that? You can think of a program shell diagrammatically. I can think of working of a shell. So let me write that. We'll take as example of bash as a shell. Now, if you wanted to run a command, so we'll write it over here as how does a shell processes command. As an interpreter, I think I'm giving a lot of X notification. So how does shell process a command? So you can think of a bash as an example. And we'll say that we want to run an ls program. So this is an, let me erase this part. Okay. So an example. So this is an example which we want to take. That you're running something like this. It's a shell command. So diagrammatically, you can think this command line which you're seeing, that is a bash, and this is another exe. Another exe. So you can think this is an something. So what bash does internally, whenever you give an input, that command. So this goes as an input. And what bash does, it actually tries to fork itself. It uses a concept called as fork. A fork is like a spoon, you can think, doubling itself. So by doing fork, it actually creates two different instances of itself. So in Linux machines, always remember, a process is created only via creating its duplicate copy kind of thing. So one can replicate itself and then create a new process, a duplicate process of its, and then reap that as a part. I think I'm not well placed. This is not the way to logically connect. I'll just say fork here maybe. Yeah, because after fork is where you want to see the changes. Yeah, now it looks okay. And then we can say and if you look at fork in general, then it says that if you have a return value as say 0, then it is a child process. A fork duplicates everything but the return ID in the machine. And CID, child's ID, okay, is what is returned in the system. So this is your parent process. And this is your child process. So now you can think of that it is one bash here, exe, and another bash exe. Now once that's done, what shell does, it actually uses one more API on top for the child function. So it does. It calls an API here, which we call it as an exec family, executable. What it does, it reaps the previous program. So exec system call. So what it does, it actually reaps the current process image. By the current. Or instead of that, replaces. Okay, so this you can think as that it is trying to replace the bash part in your program. So virtually it will become from here and another exe instance. And this will become a list.exe. Something like this. Logically, we can think we're drawing that now. It's like this. Something like this. And the context of this is gone, correct? So you can think of, because it is replaced, this process image does not exist, right? Bash is gone, and it's nothing but the ls.exe which is existing for us. Now once the ls.exe completes its job, so it will perform naturally an exit. So it performs an API with exit 0 success. It means the program is legally completed its job. And from here, what you do is you connect back, go back, again back to the prompt. Okay, like while one means you're back to this dollar prompt. So the next dollar prompt, so definitely you can think of I like to logically more correlate the diagram. Again, it comes back to bash, and we have one more shit. So back to and you have your dollar back, which you can think of like. So this is the status of how the entire life cycle of a bash is. And then again, you can type some more commands. So right from whenever it's typed ls, these all things happen. First, bash tries to replicate himself so that he stays alive. Bash will keep running as a parent and keep monitoring the child to finish his job. And once it is done, it will come back and wait, give the prompt and wait for the user's next command. So this is the typical cycle of every, right from rudimentary to a very enterprise class of shell. And these shells will have several purposes to serve. So certain shell programs are customized for certain hardware. For example, there are some kind of a shell which are used as rescue shell. Now, when I say rescue, how does it rescue us? Like, for example, some router or set-top boxes which you're running, and if you want to perform some kind of configuration change or some resets are happening because of bad configuration, there are mechanisms by which, through serial line or some other USB port, you can connect to a development machine and it opens up a shell to you. And that's a diagnostic shell, or the shell via which you can have an access to the configurational files and you can edit them. So they're heavily tuned or customized for that, router or some hardware, set-top box. So they will have different commands. You may not expect that it will be having a general shell where ls, date, vim, editor, and all those things will be working. No. Okay. It will be naturally customized for that hardware. So maybe IP address, setting the change, removing the net filter based, commands and so on. Firewall checking, enabling and disabling of certain configuration services. Those will be customized. Okay. Similarly, you can have some certain shells. You can think sometimes, like say, bootloader can be another example. Like it may provide you command line editor. When a system is booting and you want to perform flashing or loading a kernel, loading this, they may provide you a set of commands, setting up a new IP address, temporary IP address, setting up DSCP configuration, or knowing about the environmental variables, setting up a directory from where this target boot should read the content from your host, and so on. So all are a very good example of command line based UI, and they are very heavily used in embedded applications. So hope this is clear and it is understood by everyone. So far so good. All fine, right? Says yes. Okay. Now let's see what are the things we can do in a shell. So naturally, there's a shell comprises of the command, and these are two types of commands. What you saw as an example over here was an external command or a separate program which is given as an input. Now, apart from this, bash also provides some internal commands by which bash is used for programming purpose to automate environments and do a lot of jobs in build. For example, bash programming is used for automating a lot of tasks by writing bash scripts, shell scripts. So though a lot of people are saying that it's getting outdated and all, there are a lot of legacy system which is completely built on top of this automated scripting. It is a highly desired skill in an embedded domain. Typically for in the automation side, they use, apart from Python and other scripts, they prefer using using a bash. Now let me have a new share. And to switch to your notes. So shell as a program contains a lot of things. It provides you inbuilt variables, expressions, control mechanism for looping. It is also feasible that when you write commands, you can pass command line arguments. You saw like ls minus l minus I minus a minus b. Like that, you can provide hell of an option, which is nothing but your command line argument. You can also perform something like functions. These functions are not like, fully first degree complied functions or formal functions. It's like, an alias via which you can group a lot of commands together which can execute, something like that. And then you have something like functions. Sorry, I spoke about it. Now you see variables. There are three types of variable in shell. One of them is called as local variable. One is called as export variable. And another one is referred as environmental variable. Now environmental variables are always referred via caps. Local variables are the one which lifetime is within the shell. Shell is over, the variable is gone. Okay. So as for example, assigning of the shell based programming is very, very case sensitive. Okay. For example, you can see x assigns to 10 is in an incorrect assignment. It is not a correct assignment. One second. But x assigns to 10. There is no space from before and after x, and that is the correct initialization. So these are some syntactical, woos which we need to remember. So if you're coming from a C programming background, suddenly, shell scripting will, haunt you. It will say what nonsense we are writing. But it's for a different ballgame altogether. It's not a programming aspects for coding and solving certain algorithms, but it is to more of, automate systems. Now, how do you print a variable? Instead of using a print, you can use some command called as echo. So echo is a command via which you can print an expression variable. How do you print? By prefixing a dollar. So if x was assigned to 10 in line number 20 in this example, then to print, I can say echo space $x. Now, it's also feasible that, when you write some commands, it outputs a lot of result. And you want to store this result in a variable as a list. That is feasible by using backquotes. So backquote x assigns to date. So the output of the date will be stored in what? X. If I say echo $x, you will get the value of the date split in x. Okay, also used as this. Example 20, line number 29, 30, 31st is an example of environmental variables. Environmental variables are meant for, setting up and providing you some ease of, system setting. For example, by default, a path variable is a special variable, environmental variable, which sets the path for all the binary executable files which you're going to use. For example, if you wanted to use ls, in order to make use of ls, you had to write actually /bin/ls. Why? Because when you type ls, the shell has to know where this ls resides. So path variable, environmental variable, helps the shell to understand where is this particular variable residing. So that is something which is related to the environmental variable. So you can see like path, or you can see like shell, or you can see like say term. So these are some very basic examples by which one can know about. I've been explaining here a small example for how do you set an environmental variable. So usually it is required. For example, you install some kind of new tool chain, okay, which has all the binaries. The shell may not be able to recognize it unless until you set the path to saying that, okay, this is my exact path where your binary is. Now here a small example. Line number 34 is trying to say you their path assigns to /bin. Now there is a multiple path being assigned. So that's one of the directory to look for, where it will search for a command which you have typed. The second is sbin as a directory to look for. The third is /user/bin as a directory, and blah blah blah. So you can keep giving that. Now, when you give dot, it means you also look for the current directory. If you're running a command which is available in the current directory, it will look for that. So this is about how it works. Now, to control, there is something like expression. Control is like if-else kind of stuff, right? So there is no, symbols like greater than and less than kind of a thing. Though Bash has introduced it, you have to write a program which is backward compatible with other shell programs also. So that's why these are some way by which you can perform some kind of numeric comparison, like dash gt is greater than equal to less than equal to not equal to. You can also write some testing of the script to say that whether it's a file or directory or a character device file or a block device file or it is an executable file. If it is a file, whether it has a read-only permission, write permission, whether it's a symbolic link or a socket type of file. So you may want to write some script by which you would like to perform this kind of automation task, identifying a certain type of file and making a copy of it, or making certain decision, changing the permission, reading something from it and writing to somewhere else, and so and so on. String-based symbols like equal to, not equal to, and z. Equal to is to compare two strings. Note that is not double equal to, it's just a single equal to syntax. Not equal to is an example of if the strings are not equal. And the third one is like if the string is empty or not. So minus z. It means an string variable exists, but it is empty or it is not empty. Logical means more than one commands can be combined together by using and or. Not is negated. Now, there's another command called as if-else. If-else is a very tricky one here. It's a syntax. If after that you must have a space, then a square bracket must have a space, then the expression which is going to be true to execute this. Again, after expression, like for example, you can think of if it is a file, do something, copy, or if it is a directory, find the name of the directory, or who's the owner of the directory, something like that. Remember, after if, when you press enter, then is a syntax. After pressing enter, you can write an expression. Then if you have extension, you can say phi. Phi means opposite of if and a syntax. Looks very weird, but that's how it is developed. Same goes with nested ones. Only the thing which changes here is elif. Elif is a syntax to check for else if as a multiple condition. You also have something like switch cases. The keyword is using case. By using at line number 98 case, certain expression, then in. And then you have, the numbers like 1, 2, 3, and then semicolon for ending the statement, and 1 is syntactically to close the line. So this is like star means default. If none is mentioned, it will come to default. Again, because you started from case, opposite of it is going to be ISAC. Yes. So that's the end of the case. Now there are three kinds of looping also supported in the shell. One is while, another is until, and there is for. Now when you use while, again space, square bracket space, expression space, square bracket close, enter, and then do and done, and in between whatever expressions you want to write. Same goes with something like until. Only the difference is while runs while the expressions are true, and until run as long as the expression is false. So you can think of some alarm or something is wrong. So until will keep working, and once it becomes right, until will stop, function. It means the health of the system is back, so it's okay, kind of a thing. Just giving an analogy of to make use of until. Command line arguments. Shell typically allows 9 command line arguments to be passed, and all of them are stored in a certain special variable. Special variables are named as $1 to $9 for command line. We also use shift as a keyword to perform positional shifting. Okay. in the situations where you have command line arguments more than 9. If you pass more than 9 options at command line, then you can use something like shift. And you can use set to store the command output to command line arguments. It means if I say set, and then in backwards, if I run any commands, the output of that will be automatically stored in the special variables. The shorthand used for storing certain portions like filtering and getting some information about it. As I said, there are some more, like $# gives you the number of command line arguments. $* gives you all the parameters passed. $$ prints the shell ID. What is the shell PID? Shell ID kinta, I should write it as shell PID, which is process ID. And then shift, positional shifting, set to place. As I said, functions are not very strong and first degree functions, or first class functions. Function does not take any parameter like this. You have to pass manually. So if I say start and we are running the program, the problem with this function is that you have written the function. But to call this function, you have to name the function name after the function call. Okay. Now, if I run this particular program, it will not run. It will give errors. The reason is you are using this special variable like $1, $2. And by using expression, you are trying to find the sum of this. The problem with the function is that it hides the special variable. So $1, $2 will not be visible inside a function. So another way is that before the function starts, take some symbol like X and Y in this example and initialize them to the command line arguments. And then run X and Y for the expression being handled. So this is the correct form and portable form. And then of course you can call the function. You can see the call of the function is just like any command. Now based on this, I have written some kind of assignments which you guys can try later. Now let me show you a quick demonstration on all this. So we get into this and we'll write the first script, say hello.sh. It is not mandatory that you should have a .sh file, just trying to give you an example. Now the first line of the shell is the most important question which is asked in every interview. What is the first line which we give? The first line is something like exclamation mark, which is shebang, and then followed by /bin/sh. The special line, okay, in the shell with a pound. It talks about calling this interpreter automatically. It is, though it looks like a comment, it is not a comment. It's a special comment which asks the interpreter to use sh as an executor. This is a sample comment line. So everybody will ask this interview query that, hey, you guys have done, do you know what is the first line of the shell script which appears? You have to say, yeah, it is a shebang, followed by /bin/sh. I'm aware. We have used in our shell programming, so and so. Now assume that we wanted to accept some number. We can say, okay, echo. Then we can say something like enter a number. And then we can say read, say n1. we can do the same thing once again by saying, okay, enter another number. We can say enter. Now what you could do is we can sum this up. You could say sum assigns to back quotes expr, remember, and then dollar n1 space plus dollar end backspace. Sorry. You can say okay. Let's try to run this. I can say sh followed by my hello.sh. Say 123. Another number is going to be 223. I can see there are some syntaxes which is getting mismatched. I'm just trying to highlight this is the place where you have an error. Remove this. To debug the shell, sometimes you start sh-x. It tells you plus plus means where is the error and where is not. It's a very common question. What is the debugging mode in? How do you debug in shell? sh-x. Now you can see numbers are going well, but it says there is an unexpected line. Correct. Actually, it started from double quotes, but you're not closing from double quotes. That's one of the options. Now you can see everything is corrected. So sum of 123 and 226 is 346. Fair enough. So this is how you can, automate and script to do various certain utility jobs. Okay. Not only numeric jobs, but some automation jobs, some configurations of the job, file, backup, this, that. All those things can be achieved. For example, if you wanted to know about whether a system is having, say, is file .sh. So we can open is file or not. Then now it's a is a file. Something went wrong because file name is file list. You can see you cannot execute directly the shell. So we have to either say sh and execute. Line number 13. Okay. So roughly, I'm just trying to give an example that this is how you can keep a track of, whether it is a file or not, something like that. You can see there's some syntax error. Line number 12. I'm just trying to show you guys as such. As an execution, I'll say as such and then try run. Give the file name like dot. It says at line number 11 it has some issues. I thought somebody is going to point. If it is if, then fee must be there. And now it's not a file. Dot dot is a directory. Correct? So it's working well. Shell program is done with this kind of a style, guys. Okay. So based on this input, I would like you guys to, do some work and try do some kind of an assignment for yourself. I'll be sharing you a document and then you should work on it. Try to see if you can practice this because it needs some practice. I cannot just be very fast, guys. If I speed up this, it will become a challenge. So just want to keep it here and give you guys a chance to, session this up. And then we'll come back for the next review. Maybe we'll have it on the coming week, Tuesday, after you have practiced for 2-3 days. Have a quick review on what you have done, like combine filter commands, do some runtime task to you and see if you can do it, and I assist you and finish it. And then go forward the next accordingly. Okay. So yes, as of now, let's keep it here. And let's catch up again in the next session.